Okay, in this lecture, we will be solving exercises from the previous two lectures, the ones on confidence interval estimation for population mean mu. We will solve questions when the sigma, which is the population standard deviation, is known, and questions when it's unknown. Okay, before you solve with me the questions in this lecture, please make sure that you have completely watched the two previous lectures on confidence intervals, because we cannot do a review now of everything. You need to know everything from the two lectures so that you can pay attention to the solutions. So if you haven't yet watched parts of the previous two lectures, stop this video, go back and watch what you didn't watch yet, and make sure that you solve the examples in these lectures with me, please. Okay, so we put it into two parts. Part one will be when sigma is known. So we will compute confidence intervals for mu when sigma is known in part one, and we had 5 questions. But Alunud insisted that we add one more question for you, and it's one of the nicest questions. Please try solving it right after you finish watching this video. We also made it a multiple choice question, so you know that the answer is one of them. So you know the answer is there, figure it out, and it's similar to one of the questions that we will solve in this lecture. Then part 2 is when sigma is unknown. So we had 7 questions in this lecture. You will see those are the 7 questions. The highlighted ones are the ones that I'm going to solve, by the way. So from lecture part 1, which is the first lecture on confidence intervals, we'll do problems 2 and 4. And then from sigma is unknown, the second lecture on confidence intervals, we'll do 2, 4, 5, and 6. So in total, we will be solving 6 exercises from the total of 12 exercises that you had in both lectures. Okay, now Alunud has prepared for you a review of the 2 lectures, but it's a crash course, like it's a very quick review, assuming that you watched the lectures already. And it goes like this. So the first page, she reminds you of when sigma is known, what to do, okay, whether the population is normal or not normal, and if sigma is unknown, also what you do in each situation. You see, for the sample size, we take it large or small, and the population normal or not normal, and sigma is known or unknown. So when you read any question, you need to first write down all the given so that you know which one of these to use. So what we suggest is that you print out, of course you would print out the whole lecture, but keep this one, this and this one, and this one with you all the time while you're solving the exercises. Okay, so those 3 have a good review of everything that you saw in the last 2 lectures. Good. So now we will start solving the exercises. Okay, so let's look at the first exercise. The first exercise says, it is known that the amount of time needed to change the oil on a car at ADNOC stations is normally distributed, very nice, normally distributed, with a standard deviation of 5 minutes. So sigma is known. A random sample of 16 oil changes have a mean, or has a mean, here it should be has, a mean time of 18 minutes. Okay, so let us write down what we know so far. What's the given? So we have a random variable x, and x, I will just highlight it and you write it down. What is the thing that is normally distributed, or what is our random variable? You can read easily. It's the amount of time needed to change the oil on a car at ADNOC station, or at ADNOC stations. So this is x. So I will just put that x is the highlighted in yellow. Okay, or we can put x here also. When you're solving the question, it's nice to write on the paper everything that you know. Okay, so that is x. And we know that x follows a normal distribution. So x is normally distributed. So we write it like this. And standard deviation sigma is given to be 5 minutes. Okay, it's good to always remember what are the units that are used. So sigma is 5, and then a random sample of 16 oil changes. So n, the sample size, is 16. So notice it's less than 30. Anyways, so continue. A mean time means x bar. So this is the sample mean, because we took a random sample and we found that the mean of this sample is 18 minutes. So you'll write here 18 minutes. Okay, so let us quickly say what we have. From here, you can say that I know that this is a situation where sigma is known. Good. Sample size is 16. So this tells us that it's less than 30. Okay, so it's a small sample. And our random variable is normally distributed. Now, what is the question? Of course, we have the sample mean given to us also. Yeah. Now, what is the question? The question says, in part A, find the 99% confidence interval for the mean time needed to change the oil on a car. So in part A, we need to find 99% confidence interval. So our confidence level is 0.99. This is what's given. That is the 99% confidence. So this is 99% confidence. Notice that also this means that the level of significance alpha is 1 minus c, which is 1%. Good. So we wrote the given. Now, let's see. So sigma is known, the sample size is small, and x is normal. Here, you can check. Sigma is known. The random variable is normal, and or the population is normally distributed, and the sample size is small. So immediately you know that you are in this situation here. So your confidence interval will take this form. So let's just write this on this page. So I know that it will be, I'll write it here. So x bar plus or minus z sub alpha over 2 times sigma over the square root of n. Very nice. Now, what do we know from these, from the given? We know x bar, okay, it's given here 18 minutes. We know sigma is known, 5 minutes. And we know n, the sample size, is 16. So what is left from this formula in order to solve the question is to find the last unknown in the formula, which is the critical value z sub c. And you remember also, we also known as, or we write it as z sub c. And in this case, so this would mean that you can write it as z sub 0.99, because c is 0.99. Or if you want to write it in terms of alpha, you will do z sub, and then alpha over 2. Alpha is 0.01 divided by 2. You'll get 0.005. Okay, and you can write it as sub. Okay, so z sub this. But it's okay. We can use one of them. Remember that z sub alpha over 2 and z sub c, we use them interchangeably. So we can use any of them in any question. Sometimes I use z sub alpha over 2 and sometimes z sub c. Okay, so now we know everything. Only we need to know what is z sub alpha over 2. Do you remember how to find this? Well, we need 99% confidence. You can use the online calculator, but there is a small table that is easy for you to see. Here it gives you the confidence level, this table, this is C, and it gives you the Z sub alpha over 2. You can use the online calculator to find it, but I feel that it's easier just to use this table. So 99% confidence has this Z sub alpha over 2. So this is our Z sub alpha over 2, or Z sub C, 2.576. So you can say that now we know that this is Z sub alpha over 2 for 99% confidence is what was it? It's 2.576. 576. Great, so you are done. Now you only have to find the confidence interval. So you'll say that my mean is going to be between the two values. So x bar minus z sub alpha over 2 sigma over radical n, and on the second half you will put the plus z sub alpha over 2 sigma over radical n. Now just write what they are. So let's do it just one by one. Okay, x bar, so I will start, of course, with this one. X bar is 18 minus z sub alpha over 2. We just found it. It's 2.576. I'll put parentheses times, and then the fraction is sigma, which is 5 minutes, divided by radical 16. Which is the sample size. And on the other side, mu is less than or equal, the same thing except you put a plus. So 2.576 times 5 over radical 16. Actually, radical 16 is 4. We already know it, but let's use a calculator to find this. So now we will put the calculator here and do 18 minus, now we need, still we can put open parentheses, and then inside 2.576 times, now we need a fraction, so we'll put 5 divided by radical 16 equals, so here this will be 14.78 less than or equal mu less than or equal, and now plus. So just go back to your calculator and instead of minus put plus equals. So this will be 21.22. Of course, this is given in minutes also because the sample mean and sample standard deviations are in minutes. So we have solved it. This is the answer to A. Okay, so now A is known. We found the 99% confidence interval for the mean. So in part B, it says interpret the confidence interval in part A. It's very simple to interpret the confidence interval. If you watched the 2 lectures before, you know already what to do here. You will say, we are 99, because we took 99 in this question, 99% confident that, and then you say, what is mu in this case for this population? It's the time needed to change the oil on a car that goes to ADNOC. I will write here mu, but you understand that you have to write what it is from the question. Okay, so this is the population mean. So this is between, and you write the 2 values that you found, 14.78 and 21.22 minutes. It's better to write here minutes when you are interpreting the result. So even here, you'll say 14.78 minutes. Okay, so it's between these 2 numbers, and you are 99% confident in what you're saying. This means that if you repeat this experiment 100 times with samples of size 16, in those 100 times, each time you take a sample of size 16 and you check the average time it takes on this sample, then 99 of these experiments will have the true mean of the population, or the true average time that is needed for an oil change. Okay, so here also the result tells us that in some sense the maximum amount of time that you would wait is about 21.22 minutes. So this is, and remember that the smaller one, we call it the lower confidence limit. The upper one, we call it the upper confidence limit. Just remember this lingo for the confidence intervals. Okay. One more thing before I go to the next question is that, because a lot of you asked me this, the margin of error is this part. All of this together, this part of here, of course you see it there also, this is what we call E, the margin of error. Margin of error. And it is the thing that you subtract and add to your mean. So it's the one that you see here inside the parentheses, the margin of error inside the parentheses. So if we take the 18 out and we put equal, this 3.22 is the margin of error. So I will just say it here. The margin of error for this question is 3.22. Of course, also it's in minutes. Okay, so actually, I just want to make sure of something. So it was, 3.22. I don't know why I tend to forget things quickly when I'm recording the videos. Okay, so this is good. Now you understand and you remember the margin of error. This, when you print the document, you know, I put this after each question so that we can refer to it quickly. Yeah. So, but you don't need, you just need one of them. So when you print, you can just print one of the pages that come right after each question. So let's now look at the second question, which is problem number 4 from the first lecture on confidence intervals when sigma is known. It says that each of the following is a confidence interval for the true average time to respond. This should be to respond, or the average response time to an editing command with a new operating system. Think of the operating system, maybe Windows 11, that is coming soon, and they gave you here 2 confidence intervals. Okay, good. So what is the question about these 2 confidence intervals? It says in part A, both intervals were calculated from the same sample data. Good. So the confidence level for one of these intervals is 90% and the other is 99%. Okay. And then which of the intervals has the 90% confidence level and why? This is a very simple question. And then part B is more interesting. Find the 95% confidence interval. Well, that's really a nice question. So for part A, let's do part A first. Let's just remember one thing, is that when you have, if you want to be more confident, if you watched the first lecture, I explained this for about 20 or 30 minutes to make you understand it. The more confident you want to be, the bigger the interval will be. So if you want to be 99% confident, you will be using a longer interval. So let's say this here is your sample mean. So if you want, for example, if you want 95% confidence, or 90, let's say, 90% confidence, let's say it's this interval. Okay, this, for example, would be 90%. Now, if you want to be 99% confident, you will get a bigger interval around the sample mean. Okay, so this is very simple to see. It's because the margin of error for 99% confidence will be bigger than the margin of error for 90% confidence. And why is that? Is because you can see here the margin of error. You remember this was the margin of error? Actually, you can take any of them. We don't yet know, our question is which one of them, but we know that sigma is known at least, because this was a question from the lecture about when you have the population standard deviation is known. So notice that this is the margin of error, and let me just write it. It's z sub alpha over 2 times sigma over radical n. Now, the population standard deviation is going to be the same for both of the samples, and the sample size is the same. So this is the same for both 90 and 99. So, and we remember we call this sigma x bar. It was the standard error of the mean, or the sample, or the standard deviation of sample means. Yeah, this we did before when we studied the sampling distribution. But okay, so if it's the same for both of them, for 99 and for 90, sigma x bar is the same. So the only thing that will be different is z sub alpha over 2. Now look here, for 90% confidence, z sub alpha over 2 is 1.645. For 99, it's bigger, it's 2.576. So when you multiply it by the same number, of course, the 99% confidence will be a bigger interval. Okay, that's very nice to know. So the bigger interval is the 99. Now look back at the 2 intervals. Which one of them is bigger? This one of them goes from 84.7 to 105.3. The other one, so here 70, yeah, the other one goes from 88, so it starts here. Let's say this is 88.42 to 101.58. So you see that this one is the smaller one. This is the smaller interval. And so it is the 90% confidence interval. And so this one here will be the 99% confidence interval. So you see, the first question was not that difficult. we were able to solve it immediately. I'm going to erase this because the second part is the more important part. It says find the 95% confidence interval. Okay, by the way, 95% confidence is going to be between the two. It's going to be here. Okay, so we need to find this interval. So to find it, I need to give you the lower confidence limit and the upper confidence limit. But the easiest way to do it is first, let's ask ourselves, do we know X bar? Well, what you know is that X bar is always in the middle, is in the middle of the confidence interval, or is the center of the confidence interval. Let me keep on saying middle or center. Let's say center of confidence interval. So what we can do is to compute X bar, I'm going to, let's now choose either 99 or 90%, the ones that we are given already. So I'm going to choose the 99% confidence interval. Now, what is the middle point in this interval? Okay, what is exactly the middle point? How do you find the middle point between 2 points? It's the average of the 2 points. So add the two numbers and divide by 2 to get X bar. So you'll say X bar is 84.70 plus 105.30 over 2. Or you can use this 90% confidence interval, add the lower limit to the upper limit and divide by 2. I'm going to show you both of them just so that you see that you get the same answer. Actually, we need the calculator now. Okay, so let's do it. We need a fraction and we will put 84.70 plus 105.30 divided by 2 equals 95. So very nice. This we get 95. Oh, I need to tell you, 95 what? Usually the response time is given in milliseconds. Milliseconds. And a millisecond is 1/1000 of a second. Okay? So we got the sample mean in this case. If you would like, go back to the calculator and instead of taking the 99% confidence interval to compute the middle point, let's take the 90%. It should be the same number at the end. So 88.42 plus 101.58. You see, you get 95 again. So it doesn't matter which one of the two you choose. Good. So now what we can do is continue now. Now what do we know? We know the X bar and we know the confidence level. Let's use the 99 for now to get the 95 from it. But how do we get the 95 from it? Well, what is the margin of error? Let's ask this question. Do we know the margin of error, which is the half of the length of this interval? So we know that this number here is, if we're taking the 99%, it's 105.30. And this number here is 84.70. And now X bar, we computed it and it's 95 milliseconds. If everything is milliseconds here. Okay. I want to erase the 90% so you're not distracted by it. So take it out. It did its job already. Okay. And now, what is the blue length here? You can do it easily. Just take the upper confidence limit minus the mean. So let's do it. 105.30 minus 95. Actually, I can do it by myself. So no need for a calculator. So the margin of error E is 105.30. That is, by the way, this is the margin of error for 99% confidence. Because the margin of error gets bigger when your confidence level is bigger. Okay? And so it is this minus X bar, which is 95. And you know that 105 minus 95 is 10, and we have 0.3, so it will be 10.30 milliseconds. Good. So this is our margin of error. Now, from the margin of error, what can we get? So our margin of error for 99% confidence, we know how it's computed. If you want to see the formula, it's here. So this margin of error, or just look at what I wrote here, okay? So the margin of error is here. And so it's Z sub alpha over 2 for 99% confidence, which is this number here, times sigma over radical n, which we can denote by sigma x bar. So we will say that this equals Z sub c, which is 99, times sigma x bar. I didn't write sigma over radical n because both of them are unknown in this case. So just write it as sigma x bar just to save space. And we know that Z sub 0.99 is 2.576, just to make sure, 2.576, yes, times, okay, 2.576 times sigma x bar. Okay, and we know that the margin of error is 10.3. So this means that 10.30 is equal to 2.576 times sigma x bar. And so what is sigma x bar? Sigma x bar is going to be 10.3 over 2.576. Now we need a calculator for this. So the calculator will give us the sigma x bar. So we need a fraction. We will put 10.30 divided by 2.576. This gave us 3.998. Isn't it inviting you to put 4? I'm going to put 4, okay? Because it's almost 4, okay? So I'll put 4. If you want to be very accurate, yeah, put 3.998, but it's 4. And let's say approximately, but we know that it's very close to 4. So it's 4 milliseconds. This is the most important thing that we calculated now because we can use it to find the margin of error for 95% confidence. This is Z sub 95, okay, which is Z sub c, the critical value, times sigma x bar. Sigma x bar, but we know this Z sub 0.95, it's here. So take this out, and for 95% confidence, the critical value for Z, which we call either Z sub c or Z sub alpha over 2. So if we use c, you will say 0.95. If you use Z sub alpha over 2, you will say 0.05 over 2. And of course, better to write it as 0.5% over 2 is 2.5%. So you write it like this. Either you use this notation or this, but at the end, it is 1.96. So right here, I will say 1.96 times sigma x bar. We just found it. It's 4. 4, which is, and now we find this value, 1.96 times 4 equals 7.84. So we're going to write this here, 7.84. So this is 7.84. This is the margin of error for 95% confidence. Good. I'm going to continue on the next page because now we got the margin of error and we know our x bar, it's 95. So here I will show you. You have x bar, and x bar is, how much was it? 95 milliseconds, of course. And we know that the margin of error, or half of the length of the interval, is, we just computed it, 7.84. It's here, 7.84. So I will put that this length, E, is 7.84. So all what you have to do now is to find these two values. Very simple. Just subtract and add the margin of error to x bar. So this point here will be x bar minus E. and this point here will be x bar plus e. And remember, this e is the margin of error for 95% confidence interval. So let's use the calculator to find it. So the calculator will give us, let's see, I need 95 minus margin of error is 7.84 equals 87.16. So this is 87.16, of course, milliseconds. And this one, I'm going to just use another color so you see it easily. Just the minus, make it plus. This will become 102.84 milliseconds. Now this interval is our 95% confidence interval. So last thing to do is just write it down. So I'll write it under Alunud. So you can say, therefore, our 95% confidence, let me write confidence interval like this, CI. It's used in all textbooks, they use this abbreviation, is, and you can open parentheses, put the 87.16, the lower confidence limit, and comma, the upper confidence limit, which is 102.84. And this is our final answer. Okay, now we found our 95% confidence interval. Now remember, 87 and 102. Notice that it will be between these two. Remember, this was for 90% confidence and this was for 99% confidence. And so the 95% confidence will be an interval between these two intervals. Okay, this is a very nice question, really. If you understand it, it will open the door for you to solve so many questions. Maybe I'll give you a hint now because I want you to appreciate this question, is that Alunud's multiple choice question, the one that she wants you to solve, oh, now you can solve it. So please solve it now. Please solve it now. Okay, if you understood this last exercise. It's almost exactly the same, except she asks you for the sample size now. Okay, and she gives you sigma. Okay, so now we go to the third question. And the third question is here. Okay, this question is from the lecture when sigma is unknown. It's from part 2. So it's we will be using something else. Okay, so this requires the second lecture. So the manager of a small shopping mall wants to estimate the mean amount spent per shopping visit by customers. So the amount spent per shopping visit by customers, this is what he's interested in. A sample of 20 customers, maybe we put it in red better. So a sample of 20 customers reveals that the mean amount spent was 207 dirhams per customer with a standard deviation of 26 dirhams. This is the sample standard deviation and sample mean. So now this is the given. So let's write it down and then read the questions. So what is given? First, what is our random variable x is? We will highlight it. So let's highlight it in yellow like we did in the first one. It's the amount spent per shopping visit by a customer. Okay, this is our random variable. Did it tell us if it's normally distributed or not? Well, okay, so I will first say that x is the yellow. So we defined it already. Now, notice that, yeah, in part C, it asks you what assumption did you make to answer part A. So probably we'll have to make an assumption on the random variable x. Let's see first. So a sample of 20 customers. So, yeah, so it's a small sample. So n here, the sample size is 20 customers. Notice that because the sample is less than 30, you have to assume that your random variable is normally distributed, or you cannot answer the question. So the answer to this is that what assumption did you make in part A? I made that x follows a normal distribution. So we need to assume it in order to be able to solve. Notice that when you have a non-normal population or distribution, and the sample size is small, you cannot do anything. Okay, so because our sample is small, we must have a normal distribution. Otherwise, we cannot solve it. Good. So now we solved C already. I can even put it here. So let's just put this down and just say that X must follow a normal distribution so we can solve the question. X is normal, and this way we solved part C. N is 20, and let's continue reading. Reveal that the mean amount spent was 207 dirhams. This is X bar. So the sample mean is 207 dirhams with a sample standard deviation of 26 dirhams. So here S is given, not sigma. So S is 26 dirhams. Okay, so let's see what is given now. Since S is given, you know that sigma is unknown. Okay, good. So we know sigma is unknown. And what else? We know that X is a normal distribution, and we know that the sample is a small sample. So here you can say this is a small sample because less than 30. N is less than 30. So we have a small sample, a normal distribution, and sigma is unknown. Okay, so you come here and you say, I have a normal distribution, small sample, sigma unknown. So immediately you know that you will be using, okay, good. So you know that you'll be using the T distribution for this question. So let's write this down, X bar plus or minus T sub alpha over 2. Yeah. So they ask you in the first question, construct a 95% confidence interval for the mean amount spent by customers. So let us start solving part A. Remember, we solved C already. Now, in part A, we need 95, so the confidence level is 0.95 or 95% confidence. Notice that this means that the significance level is going to be 5%. Okay, good. Now, what do we want? The 95% confidence interval. So remember, this is the 95. This is the confidence interval, and so we need to find the T that will give us 95% confidence. So if you look here, for level of confidence is given in the T table, we want 95% confidence. This we know already. And now degrees of freedom. We need to know the degrees of freedom. So you go back and you know that your sample size N is 20. So can you tell me what are the degrees of freedom in this case? Yes, you guessed it right. 19, which is N minus 1. This formula is always N minus 1, okay? So it's 20 minus 1, which is 19. So I have 19 degrees of freedom. So I will go here and find 19. 19 is there, and so I am almost done. I found my T. You can use, of course, the online calculator to do this. So T sub alpha over 2, or we call it also T sub C, is 2.093. So T sub alpha over 2, or I will write it T sub C. So here our confidence level is 95%. So it will be, of course, you have to also say that the degrees of freedom are 19. It was what? 2.093. So it's 2.093. Great. I have this and I'm done. You just have to write the confidence interval now, the 95% confidence interval. So you'll say that my mean is between X bar minus T sub alpha over 2 S over radical N, and X bar plus the same thing, T sub alpha over 2 S over radical N. And we need a calculator to do this. So here, so what would it be? X bar is what? 207. So 207 minus, we do the minus first, and T is 2.093 times, now we need a fraction. It will be S, so what is S? 26. So 26 divided by radical, sample size is 20. Here you put the sample size, not the degrees of freedom, and is equal to, okay, so we found it. So you can say mu is between 194.83. You can even put a 2, but I'll take it to 2 digits, and less than or equal. How about I put it in a different color so that it you can see it easily. So 194.83, and now the same thing but with a plus. So just put a plus instead. You'll get 219.1, and then 6. After the 6 there is an 8, so put 7. Great. So this is our confidence, 95% confidence interval here. Okay, so this solves the first part, part A. Okay, and we solved part C already. So all what we have to do now is look at part B. Maybe part B will be simple. Let's. So we solved A now. Now part B. Would it be reasonable to conclude that the mean amount spent by all customers is 200 dirhams? Well, look at the confidence interval. Is 200 here? Yes, it is between 194 and 219. So you can say it is reasonable, yes. What about 240 dirhams? Oh, no, it's outside the interval. 240 is far from this. So 240 no, but 200 yes, because it is inside the interval. So you can be 95% confident that 200 is inside the interval. Okay, and that solves this question, and we are done. So now please take a short break and pause the video. If you haven't solved Alunud's multiple choice question yet, the one that I told you is similar to the one that we solved before this question, please solve it now. So if you take a break, when you come back, you should have the answer to this question. Do not watch the rest of the questions before you see the answer to this one, please. I mean, you solve it, and then you can send me your solution, and I will check and let you know if you got it right or not. Okay, good. So now we will go to, take a short break. Let's wait for 3 seconds if you want to pause the video now. Okay, so now we have this question. Suppose the 90% confidence interval, so they are giving us the 90% confidence interval for the mean SAT scores of applicants at a business college is given by, okay, so the 90% confidence interval is given. So I'll write it here, 90% confidence, remember confidence interval, you can write it CI, is, and you write it 1690 to 1810. This is the 90% confidence interval. And then they tell you this confidence interval uses the sample mean and the sample standard deviation based on 25 observations. So this is our sample size. N is 25. What are the sample mean and the sample standard deviation used when computing the interval? Sample mean, so they want X bar. So let me write it in a different color. So what is X bar and what is the sample standard deviation also? Yeah. And what is S? An interesting question, this one. Finding X bar and S. I suggest that you pause the video and try solving it yourself. This is a very nice question also. So let us start first solving by putting an interval like this and put 1690, it's the lower confidence limit, and the upper confidence limit is 1810. Notice that we know that this is our 90% confidence interval. So let's say this means that C is 0.90, okay? Or you can say the level of significance is 0.10, 10%. It's nice to always write this. Level of confidence and level of significance. Whenever you have any question on confidence intervals. Okay, and now remember, they want first the sample mean. remember, the sample mean is always in the center of the confidence interval. This is X bar. We can compute it quickly. You remember? You add the two numbers and divide by 2 because it's the middle between them. This is divided by 2, which is, let's use the calculator. So I need a fraction, and then 1810 plus 1690 divided by 2 equals, yes, very nice, it's the whole, it's a whole number, 1750. So we have actually solved the first part, is what is the sample mean. Okay, from now on, if you have the confidence interval, the sample mean is always the middle. So just add the two limits, the lower confidence limit and the upper confidence limit, and divide by 2, because it's exactly between them in the middle. Great. So now I have this sample mean. Okay, let me just put the sample mean so you know how it's computed already. So this is 1750. Good. Now we want the sample standard deviation. This one will require us to think a little bit, okay? Because what do we know? What can we compute now? First is, what do we have here? Yeah, we want to compute the margin of error. Remember, the margin of error is equal to, in this case, we will be using, of course, the t distribution. It's because sigma is unknown and the sample size is small. Okay, so you cannot take a non-normal distribution because it will not be applicable. Okay, notice that. So our distribution must be normal. Did it say normal here? That's core business college. What are the sample? Okay, so you must assume that here we have a normal distribution. Okay, so the distribution of SAT scores is normally is normal. Okay, and so we were going to be using this formula for the confidence interval. X bar, we have it already, we know it. Now let us find T sub alpha over 2. Now, in order to find T sub alpha over 2 for, remember, it's 90% confidence. So here you will choose 90% confidence, and you need to know the degrees of freedom. How many degrees of freedom do we have in this question? N is 25, so degrees of freedom is 24. It's always one less than the sample size. So let's go to 24. 24 is here, and see where they intersect. So they intersect at this point. So you can say this here is my T sub alpha over 2, 1.711. Okay, or you can call it, of course, T sub C, which in this case it's 90% confidence. So you write it like this. Okay, T sub 0.90, or if you use T sub alpha over 2, you will do, remember alpha is 10%, so alpha over 2 will be 5%, so you'll put it like this. Either you choose this or this, doesn't matter. So 1.711. So I just will record this because we will use it. T sub alpha over 2, which is T sub C, is in this case, for, of course, for C is 90% and degrees of freedom 24. We found that it is 1.711. So let's write this here, 1.711. Good. So now you have it, and remember the margin of error is T sub alpha over 2 times S over radical N. Okay. Oh, yeah. So almost everything we know here. T sub alpha over 2, we just computed it. Nice. What else? The sample size, let's do in green. The sample size, the sample size is N. So the sample size here, N, we know it. It's 25. And the margin of error, we know it. Okay? How do you find the margin of error? It's just the distance between this and this, between 1750 and 1810. So you can say that this is 1810 minus 1750. And because this is an easy calculation, you can see that this will be 60. Okay, you can use your calculator if you can't see it. So this is 60. So you can say, therefore, 60, the margin of error, equals, what was t sub alpha over 2? It was 1.711 times the sample standard deviation divided by radical n. N is 25. Radical 25 is 5. So this will be 1.711 times s over 5. And so this means what we need actually is the s. This s here. I always choose the wrong colors for some reason. So, okay, so we need this s. This is the unknown. Remember, from the beginning, they asked us to find it. And once we find it, we're done with this question. So this means that s is, notice, 60 equals this. And so multiply 60 by the reciprocal of what s is multiplied by. So times 5 over 1.711. It's like everything is given except s. So do this. 60 times 5 is 300. I know this, it's simple, over 1.711. This I need a calculator for. So let's see what it will be. So 300 divided by 1.711 equals. So this means it's 175.336. Okay. Yeah, this question was interesting. Yeah, it took us a while to solve it, but I hope that you understood it. I think you understood it. I mean, if you watched the 2 lectures already, you by now you should understand everything that we're doing here. Okay, and notice that these questions, at least this one and one of the previous ones, you cannot use the online calculator to do it. Okay, the one that gets you the confidence intervals, but you can check your answer. So let us check our answer. What do I mean by checking our answer? What I mean is this. Now we solved for what? We found x bar. So x bar is here. So please take, let's put what we found in green. This is x bar and this is s. S is the last thing that we found. And now suppose that we want to check that our answer is correct. How do we check it? We want to make sure that it's true that the 90% confidence interval will be this. So now suppose that this is not given. Now suppose that we don't know this interval, but we know S and we know X bar and the sample size and the confidence level. Let us put these numbers in the online calculator and hopefully we will get this confidence interval. Let me check. So we will go to the online calculator. Yeah, it's here. So what was the sample mean? The sample mean is, let's see, 1,750. The sample size, n, is 25. The standard deviation for the sample is the last thing we computed, 175.336. And the confidence level is 90%. You see, they started telling us that we have a 90% confidence interval. Now, when I click calculate, what we are expecting to see is this. If we don't see it, it means that we did something wrong. So calculate. Let's see. Okay. So the confidence interval, 90% confidence interval, the blue, read the blue. 90% confidence interval is 1,690 to 1,810. So happy face. This means that all our calculations are correct. So this is just one way to check that the answer is correct. Okay, so this also finishes the solution to this question and we can go to the next one. Okay, so A statistician selected a sample of 16 IT managers from UAE companies. I see immediately that this is 16, the sample size. He reported, and notice it's a statistician, so this means that we will assume that this person knows what he or she are doing. It's a he. He reported that the sample information indicated that the confidence interval for the average salary in dirhams of all IT managers in UAE is, so the confidence interval is this. Yeah, but what is it, 90 or 95 or 99%? It didn't give it. Let's see. And the sample standard deviation is, so sample standard deviation is 2,000 dirhams. So the sample standard deviation is 2,000 AED or DHS. So be careful with this question. So the confidence interval, it didn't give you the percentage. It didn't tell you how confident we are. It just gave us the confidence interval like this: 28,698.8, 31,301. Good. He neglected to report what confidence level he had used. Wow, what a statistician. I mean, this is very important that he reports it. But because he's a statistician, he will be able to recover it. Yeah. So now what we're looking for is the confidence level. Based on the above information, what is the confidence level? This means that C is the unknown. What is the confidence level for this question? Wow. So the first thing that we should notice is this. First is that our sample size is 16, so it's a small sample. So n is less than 30. So we have a small sample. This means that what I mean is that you will choose small sample. Okay, but let's continue reading. Sample standard deviation is given. So this means that sigma is unknown. And it didn't tell us about the distribution, but you must know, because the sample size is small and it's a statistician who's doing this, it must be that he knows it's a normal distribution. Otherwise, he cannot do anything. So we know that it's a normal distribution. We know that it's a small sample size, and we know that sigma is unknown because they gave us the sample standard deviation S. So this means that we're going to use this formula for the confidence interval. Okay, so we know that, at least we know now it's a T distribution that we use. So let's now continue reading. So this means that what is the confidence level? That is the question. Wow. So what we will do is, how about this? First, I will draw the interval here, and the lower limit and the upper limit. And forgive me for this, but I will write the numbers. So 28,698.8, and here 31,301 dirhams. And you know that your sample mean is in the middle. Do you remember how to find this? I think you all know now. Add the two numbers and divide by 2, because X bar is exactly in the middle. Okay, so no, it's not this. We need the calculator. So let's put the calculator up. And what is it? Yeah, we need a fraction. And then 28,698.8 plus 31,301. Oh. Yeah, it seems like they're hard numbers, but yeah. Oh, this is... Would I write this, or you, can we write 30,000, please? I mean, this is 29,999.9. Okay, if you want to write it, I will write it as it is. Okay, so you told me to write it, but I wanted 30,000. But if you want to just be as accurate as possible, yeah. So it is, X bar is 29,999.9 dirhams. That's the sample mean. Good. So now we have the sample mean. From the sample mean, we can get, remember, you can get the margin of error, E. this is what? You remember how to do it? Just take this number minus the sample mean. The distance between the two is the difference. So we'll go back to the calculator now, and we will do 31,301 minus 29,999.9 equals, so margin of error is, let's write it here, so it will be 1,301.1. Okay, great. So now we have the margin of error. See, all of these things can be computed if you have the confidence interval. You just get X bar as the average of the lower and upper limits, and the margin of error as the upper limit minus the mean. Or by the way, you can also do it as the mean minus the lower limit. You try, you'll get the same answer as for the margin of error. Okay, so now what do we have? We found the margin of error, we found the sample mean, and so now from the margin of error, so you can say the margin of error is what? It is, remember, we have this formula, so we're using the t distribution here, so it's t sub alpha over 2, t sub c, let me write it, times s over radical n. Now s and n are given, and the margin of error we know it. So let me show you. This we know it, this we know it, and this we know it. So the only unknown is t sub c. So what you can do is say t sub c, therefore it's equal to e times radical n over s. That's simple algebra, yeah, to find t sub c. So e is 1,301.1 times radical n is 16 divided by s is 2,000. Okay, radical 16 is 4, of course, we know this. So I'm going to, we need the calculator to find this t. Okay, so it's 1,301.1 times, and then fraction, radical 16, even though I know it's 4, but I want you to see that, to see the formula, because if it was not a number that has a whole integer radical, then you will put the radical. It's over 2,000 equals, so 2.6022, which is 2.6022. Okay, good. This is our t sub c. Okay, please pay careful attention now. We found the critical t value. Now we want to use the t table to find the confidence level. You know, it could be one of these. Sorry for this. It's one of the confidence levels that you see here. So which one of them? So do we look in the table and try to find this t that we computed here? Well, yes, but you know that n is 16. Please pay attention to this. N is 16, and so how many degrees of freedom do I have? It's n minus 1, which is 16 minus 1, which is 15. So I know that I have 15 degrees of freedom. I'm going to also put this in green. So now look at this. You have the t and the degrees of freedom, okay? And you want to know the confidence level. So degrees of freedom 15, come here and you have 15. So please highlight, let's make it small, and highlight the 15 row. Okay, why did I highlight it? Because I know that my t has to be one of those. So let's see, what was t? T was here, 2.6022, 2.6022, it's here. Okay, so let's go up and see what would be our confidence level. So if you go up, oh, it's here. So this is what we're looking for. Put a happy face. So you can say that our confidence level or level of confidence is 98%. So now you can say these two together, having t sub c and degrees of freedom, imply that our confidence level is 98%. So see what the statistician did? He made us work backwards to find the confidence level. Usually, you know, when you use the t-table, I'm going to take this off. You already have the thing. So usually you have the level of confidence and the degrees of freedom. So for example, if they tell you 98% confidence and 15 degrees of freedom, then you can find the t sub alpha over 2. But in this case, what we had was this one and this one. And we needed from these two to come up and find the level of confidence. Great. And you can think of another way is maybe we give you the confidence level and we give you the margin of error from it and the sample standard deviation. Okay, so you can find the t, and we don't give you the sample size. Could we do that? And you need to find 15? Maybe. So think about it. How would we change the question so that n is the unknown? Is it possible? Think about it. Okay. In fact, in the question of Alunud, if you have solved it already, the multiple choice, the one here, it's asking you to find the sample size. Okay. So let's see. You can, if you solved this already, then you understand the question that I'm asking now. Okay, you could even understand this question without solving, but please solve Alunud multiple choice question. Now we arrived at the last question for the lecture, and after we solve it, you have 6 solved exercises from the chapter of confidence intervals. So this means in each lecture you had 2 examples, and now you have 6 more. So this means that you have how many? From each lecture to 2 lectures, 4 plus 6, 10. You have 10 solved exercises. So you need to do well on your assessments. And please solve the questions that I didn't solve, because I actually choose the harder questions to solve for you, or the ones that some of you asked me about. So this is why the ones that I left, the other 6 questions, they are easier than the ones I'm solving now. So please solve them. It doesn't mean that you have to solve only what I'm solving. Solve the other 6 questions that are not solved, please. So let's do this last one. Okay, so what is the question? In order to attract more young customers, a new clothing store offers free gourmet coffee and pastry to its customers. You know how long it took me to find a store that sells clothes, and seems that there is a abaya here, and at the same time is selling coffee. Okay, it was so lucky to find. Okay, so now let's see. The average daily revenue over the past 5-week period has been, average daily revenue has been this much, with a standard deviation of 1,300 dirhams. That's the standard deviation. Use this sample information to construct the 95% confidence interval. So they want 95% confidence interval for the average daily revenue. The store manager believes that the coffee and pastry strategy would lead to an average daily revenue of 6,000 dirhams. Use the 95% confidence interval to determine if the manager is right or wrong. Okay, good. So let us write down the given. So the average daily revenue. So what is our random variable here? It is the average daily revenue. So the daily revenue over the past, not over the past 5 weeks, just daily revenue for this clothing store. So you can say here it's the daily revenue. Revenue is the money they make, yeah? Daily revenue for this clothing store. Okay, so now did they tell us if it's normal distribution or not? No, but let's continue reading and check. So they said that over the past 5-week period, the daily revenue was 5,400 dirhams. So we know that X bar is 5,400 dirhams over a 5-week period. Just wait a second and we continue. Standard deviation, this is the sample, of course. The sample, 5-week period is the sample. So let's see. The standard deviation is 1,300 dirhams. And now, what is the sample size? Now, notice our random variable is daily, so per day. And we have a 5-week period. So n is 5 weeks. So how many days? 5 times 7, because each week has 7 days, so 35 days. I will put just days here so you remember why I did it, because our random variable is measured in days, and even this sample mean is daily revenue. Okay, good. So now what? Use the sample information to construct 95% confidence interval. It's already telling you use this sample information. It means that this standard deviation is S because it's for the sample, and this is for the sample mean. Okay, good. So now what do we know? We know that since S is given, sigma is unknown. Let's write this here. So this means sigma is unknown. Good. So our sigma is unknown. And what else? So we know this at least. Sigma unknown. And n, oh, good. N is 35. So it's a large sample. So this means large sample, which means that my n is bigger than or equal to 30. This happy because once you have bigger than or equal to 30, things become very easy. Now, the only thing is that since they didn't tell us that this is normally distributed, this x, we don't have to assume it because the sample size is big already. So we can say that we have a large sample size. Sigma is unknown because they gave us S. Our distribution, nothing said that it was normal, so we will assume that it's non-normal. Okay, and so we can use this for our confidence interval. Okay, so if it told you that it was normal, of course you will be using this one here. But since it didn't say, usually when it doesn't say, you cannot assume it's normal unless the sample size is small, in which case you know that you cannot solve the question without assuming that the random variable is normal or the distribution is normal. So in this case, because our sample size is large, we took 5 weeks, which is 35 days. That's why we don't need to make an extra assumption on the distribution. So now you put it not normal. Okay, so you can say here what? So what's the question? Construct the 95% confidence interval. So we need our confidence level to be 95%, which implies, notice that in this case we will be using Z, so the normal distribution, the Z coming from the normal distribution. It doesn't mean that this is normal, okay? This is just the Z that we compute from the standard normal curve. Okay, so they said 95, yeah? 95% confidence. So look here, 95% confidence has this Z sub C or Z sub alpha over 2. So this is Z sub C, which we can write as Z sub 0.95. Or if you write it as Z sub alpha over 2, this would mean, remember, C is 95, means that alpha is 5%, which means that alpha over 2 is 2.5%. So you can write it like this. And so you can write this as Z sub 0.025. Okay? You see how many times I wrote Z sub C and Z sub alpha over 2. Please don't make mistakes with this afterwards, because I did it in the 3 lectures. Okay, so now we know that our Z sub C, let's write it for this question, Z sub C equals Z sub 0.95 is 1.96. So now I know my critical value. And so what is known here? I know this. I know S, I know X bar, And I know the sample size. Perfect. So everything is given actually. So let's see. So this means therefore our population mean is going to be between x bar minus z sub c times s over radical n and x bar, so we put this in parentheses, plus the margin of error z sub c times s over radical n. And of course you can write, instead of z sub c, you can write it z sub 0.95. Okay, so this means that mu is between, and now the calculator. Nice, we're almost done. So let's see, we will put x bar, yeah, x bar is here, 5,400, minus, open parentheses, and now z sub c, so remember I'm doing this first, so now z sub c, it's here, 1.96, 1.96 times, I need a fraction, and I have s is given 1,300, divided by a radical sample size. Sample size is 35 days, 35 equals. So you can put it between, let's put it in blue, 4,969.31. Okay, to 2 digits do it. And the upper confidence limit is when you put plus, so you'll get 5,000. So here 4,000, let's put comma, so 5,830.69 dirhams, of course, everything is in dirhams. Good. Okay, now the question is, the store manager, let's read it together because this, we read it already, but now we want to answer the question. The store manager believes that the coffee and pastry strategy would lead to an average daily revenue of 6,000 dirhams. So then they ask you, use the 95% confidence interval to determine if the manager is wrong or right. So look here, he's claiming that it will make the population mean, you know, this, what he's interested in is the population mean. He's saying that it will be 6,000 dirhams. But notice our confidence, 95% confidence interval showed us that the true population mean, which is the daily revenue, is between these two numbers. And he's saying 6,000. Notice that 6,000 is much more, not much more, like 170 more, but it's not inside our interval. Because it's not inside our interval, the manager is wrong. So let's say that this is the manager here with this picture, so he is wrong to say that the daily revenue will be on average 6,000 dirhams. So what could he say that you would accept? If he said any number between these two, then it's okay. But he's giving you a number that's outside the 95% confidence interval. And you chose to use 95% confidence interval. So he is wrong now. What if you use the 99% confidence interval? You know, the only difference between the solution for 95 and if the question was instead, just think about this, if the question instead of 95 we put 99%, so here 99%, what would be the difference in the answer? It will be here, so you'll change it to C equal 0.99, and then this will be 0.99, and you will go here and find that for 99 is 2.576. So this one will be 2.576. And so what you will do is you will use 2.576 instead of 1.69. So let's see, if we want 99% confidence, then let's see if it would, if he will be right at least or not. So just go here and change this. So this will be 2.576 equals almost 6,000, but still he is wrong. I mean, this is the upper confidence limit. And you see that even if you choose 99% confidence interval, his claim is still not inside. He's saying 6,000. Even though it's close to the upper limit, but still, if it's not in the interval, you will report that he is wrong. So the manager is wrong in this question. I hope that this made you understand this question better. It's an interesting question, yeah? Okay, and thank you for watching this video. Please subscribe to my channel and put the notification on, and listen to Alunud when she tells you to like the video if it made you understand. Okay, and I will just go quickly back to tell you something. Now we have solved these exercises. This is done now, 2 and 4. So now please you solve number 1. Now you can solve 1, 3 and 5 from part 1. Of course, Alunud multiple choice, I assume that you already solved it while watching the video. And then from part 2 you will solve 1, and we have already solved 2 and 4 and 5 and 6. And so you will solve what again? 1, 3 and 7. So 3 questions from this lecture, and let's count 1, 2, 3 questions from this lecture. And Alunud added her question that really, if you solve it, you will understand things much better. I will tell you from now, if you solve all these questions, total 13 questions, I solved 6 of them for you, so you have another 6 and Alunud's question, so 7. If you solve all of them, you will be extra prepared for any assessment. Of course, you must also watch the 2 lectures on confidence interval, the first one with sigma known, the second one with sigma unknown, and solve the 2 examples in each of the 2 lectures. This will give you how many? 17 questions. Then you can teach confidence intervals to anyone after this. So I'll just go back to the last page, and thank you again for watching. And if you like the video, don't forget to like it in YouTube, and take care.